What's up, guys? In this video, we're going to go over the 3 rules of the quadratic formula that you absolutely need to know. A lot of times students just think of the quadratic formula as that formula to use when you can't solve a quadratic equation by factoring. But the reality is once you've done... What's up, guys? In this video, we're going to go... What's up, guys? In this video, I want to go over the 3 rules of the quadratic formula that you absolutely need to know. A lot of times students think about the quadratic formula as that one formula to use when you can't solve a quadratic equation by factoring. But in reality, ladies and gentlemen, the quadratic formula has a lot to it, and it can become very, very powerful. So it's really important, especially when students get out of algebra class, they're expected to know and use the quadratic formula appropriately. That's where these 3 rules are going to come in, and that's what I want to explain to you in this video. So let's go ahead and get started with the 3 rules of the quadratic formula. Now, the first rule of the quadratic formula that we need to go over and we need to remember is to apply the quadratic formula, your quadratic has to be equal to 0. So let's go through a classic question or a problem that a lot of times students will get and see where students would make mistakes. So for example, or you can see in this example, I have x squared is equal to a 5x plus 3. Now, ladies and gentlemen, when we are using the quadratic formula, no matter what's happening, sometimes we have to simplify, sometimes we have to expand, but we all know we can only use the quadratic formula when we have a quadratic, right? So it has to be a quadratic. That means you can see we have my x being squared, but what we have to do is get everything over to the same side and set it equal to 0. That's the exact same process we use for factoring. But I think since we're not factoring and we're using this formula, students just sometimes get lazy or they just forget. Then they say, oh, well, I'm just going to use the quadratic formula as it is because I can identify my A, B, and my C. Now, because this is a video where I want to do some explaining about at least the quadratic formula, I think it would make sense for me to at least go through the quadratic formula at least a couple times in this video. So what would you do in this case? The first thing you're going to want to do is get everything over to the same side so the quadratic formula is equal to 0. So first thing I'll do is just go ahead and subtract a 5x on both sides. So now I get an x squared minus 5x is equal to 3. But again, I still need to get rid of that 3. So I'm going to subtract a 3 on both sides. Now I have an x squared minus a 5x minus 3 is equal to 0. Now we can either try to solve by factoring, but if it's not factorable, we need to go ahead and use the quadratic formula. So when we're applying the quadratic formula, our a, b, and our c come from the quadratic when it is equal to 0. So you can see ax squared plus bx plus c is equal to 0. That is where I'm going to draw my a, b, and my c. Now, again, the formula for the quadratic formula, which I agree, if you're not always doing it day in, day out, it might be forgotten, right? But I don't want you to rely on a quadratic formula song or doing flashcards. All I simply want you to do is have practice with the quadratic formula. And trust me, the more and more practice you do, the easier it is for you to be able to do it correctly. So the quadratic formula to find the solutions of x that satisfy this equation is going to be x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over a 2 times a. All right. So all we're simply going to do is once we have it set equal to 0, you're going to plug in these values a, b, and c into this formula. Now, again, if you don't have a number as a coefficient, we can always assume that's going to be a 1. So in this case, a lot of times I like to list it. A equals 1, b equals a negative 5, and there we go. And c is going to equal a negative 3. Okay, so let's go ahead and plug it in because, I mean, we might as well at least do 1, and so you guys can see. So x equals opposite of b. Now, again, it says opposite of b, not negative b. Right? So b in this case is a negative 5. So now my b is going to be a positive 5, and that's going to be plus or minus, let's see, negative 5 squared. Even though it doesn't really matter if it's negative 5 or positive 5, I always just for accounting purposes, like to put it in parentheses and write it in there. And that's going to be minus a 4 times a, which is 1, which is nice in this case, times a negative 3. Okay? And that's going to be all divided by a 2 times a, which in this case is 1. So let's go and do a little bit of math here. You can have a calculator, but I think a lot of these aren't too bad, right? So if negative 5 squared is 25, negative 4 times 1 is negative 1, times negative 3 is a positive 12. So 25 plus 12 is going to be a 37. So therefore, I'm going to have 2 solutions. That's why the plus or minus is in there. So 5 plus or minus the square root of 37. And again, remember, this is all divided by 2. Now, there's a couple different ways we can go ahead and rewrite that, but for a lot of teachers or based on the directions, that is going to be perfectly fine. All right, now let's go into number 2. And this is probably the easiest one. I mean, probably the most important that a lot of students will remember when they are learning the quadratic formula. And there are 3 possibility of solutions. So we're going to have 3 possibilities of your solutions. Now, the last question that I just did, we had 2 solutions, right? It was 5 plus square root of 37 divided by 2 and 5 minus square root of 37 divided by 2. But there are other possibilities that we could have, okay? And that makes no more sense or no more better sense than when we look at the graphical approach. So what we're trying to do, again, is we're solving a quadratic, okay? Now, a quadratic has the shape of this U-shaped graph, what we call the parabola. So you can have it where it crosses the x-axis once, which would be one solution. We can have it where it crosses the x-axis twice, which would be 2 solutions. Or we can also have an example where it doesn't even cross the x-axis at all, which would mean we'd have no solutions, okay? Now, where do we get these and how can we identify these? And this is one of those things that when students are outside of learning the quadratic formula in isolation, they just kind of forget about it. But it's critically important, and it's something that comes up over and over again. So it's really, really important to make sure you remember this and how to identify it quickly, right? We don't always want to go through the quadratic formula through start to finish to be able to identify, does it have 1, 2, or no solutions? What we need to do is look at the discriminant. Now, the discriminant is what is under our radical. So when we have 1 solution, that means that we're going to have a b squared minus 4 times a times c is going to be equal to 0. That is going to be our way that we can understand and identify when we have 1 solution. When we have a b squared minus 4 times a times c is greater than 0, that is going to tell us when we're going to have 2 solutions. Now, when we're going to have 2 solutions, there's also another caveat we can look at. If the number if our discriminant is what we call a square number, so let's go through the square numbers like 1, 4, 9, 16, 25, 36, 49, 64, 64, 81, 100, 121, 144, right? You get the picture. If those are square numbers, then what that means is we are going to have rational solutions, okay? So that means they can rewrite as an integer or a fraction. So that means if it's square, then that means it's going to be rational. If it's not square, like let's say, I don't know, 37 or 9, or 9 is a square number, geez, or like 10, if it's non-square, then we're going to have irrational solutions. So non-square would be irrational, okay? So that's kind of important to remember, especially if you feel like you're looking at graphing or verifying solutions. That's always helpful. And the last one is going to be when we have no solutions. So that case is going to be when b squared minus 4 times a times c is going to be less than 0. So that is going to be no real solutions, or once we start getting into the complex number system, we understand that's going to represent as 2 complex solutions. All right. So it's just really, really important to remember that. And there's a lot of different problems that we can use this understanding to our advantage. Now, rule number 3, and this is my favorite one, but guess what, guys? The quadratic formula works for all quadratics. Okay. And that's one thing that I see students kind of forget works for all quadratics. And they get quadratics that don't look like the typical quadratic that we would factor. And they're like, they kind of forget about even using the quadratic formula. Let me give you some examples. If I had an x squared plus 7x is equal to 0. Now this one actually wouldn't to be too bad factoring. You factor out the x, right? You can factor out the x and then use the 0 product property to go ahead and solve. Okay. But again, you can do this with the quadratic formula. A would equal to 1. B is equal to 7, and C is equal to 0. All right. You can also do it like this, x squared plus 7. In this case, you could use the square root method to be a lot faster. But again, the quadratic formula is going to work. A equals 1, B equals 7. Oh, no, sorry. B equals 0. What am I doing? So B is going to equal to a 0 and C would equal to 7. But again, plug them in. Like, it works. It doesn't matter if B is 0 or C is 0. The only number that cannot equal 0 would be your A, right? Because then it wouldn't be a quadratic. But the one I love the most is going to be, what about when we have fractions? Like 1/2 x squared plus a 1/3 x minus 1 is equal to 0. Can you use the quadratic formula for fractions? Yes, ladies and gentlemen. Of course you can. But here's one thing special, right? It's really not about, I think you guys agree, like, of course you can plug in fractions, and nobody really wants to do the quadratic formula with fractions, right? I mean, nobody wants to do it with the big numbers. Nobody wants to do it with fractions. So here's one thing I want to tell you. When you're looking at a quadratic equation or a quadratic on the graph, okay? And if you remember graphing quadratics, one thing is what our A is, that is going to be our scalar, okay? That's going to be our vertical stretch or compression. But guess what? When we multiply a quadratic by a different number, all that's simply doing is either vertically stretching or vertically compressing our graph. So if I was to multiply everything by 6, I'm actually not going to be changing the solutions of the graph. All I'm simply going to be doing is vertically stretching the graph. So now the graph is going to look maybe something like this. Okay, so it's just going to be much more simpler. If I was to like divide everything by 6, I would have a much wider kind of graph. But again, ladies and gentlemen, the solutions are not going to change. So yes, could you do the quadratic formula with fractions? Of course. Could you do it with very, very big numbers? Of course. But it's much easier to be able to see if you can find a scalar that can either make the number smaller, or in this case, non-fractions. So therefore you can do the quadratic formula without worrying that you have to make, without worrying that you might make some errors and something like that. So if I multiply everything by 6, look what happens. I'm now going to have a 3x squared plus a 2x minus 6 equals 0. I think you'd agree with me. This is going to be much easier to work with doing the quadratic formula than using the quadratic formula over here with fractions. But guess what, ladies and gentlemen? The answers are going to be the same. If you don't think the answer is the same, then go ahead and work them out and show me your solutions down below and comment that they are indeed, I was right and you were wrong. But either way, I hope this video was helpful for you. I hope you understand these rules of the quadratic formula and you keep them close to you, because even if you're just learning about the quadratic formula, this is something that's going to stay with you for the rest of your time in mathematics. I hope this video was helpful for you, and I'll see you in the next one. Cheers.